Woohoo! Last set of notes for the week. You will not have homework over the weekend. Love that. And today we are going to go ahead and move on to lesson 2.6. And with lesson 2.6, we will be adding and subtracting fractions with unlike denominators. Don't worry, we'll get through this together, I promise. So remember, to add and subtract rational numbers with unlike denominators, find a common denominator using one of the following methods. I don't care which one you use. Method 1, find a common denominator by just multiplying one denominator by the other denominator. Or, if you want to get all crazy, go ahead, find the least common denominator. Now in our examples today, I will use both methods. Just to get you some practice with both. And don't forget, we are still having positives and negatives. So you now have to switch your brain to the rules for adding and subtracting integers. Remember, go back and use your green integer rules note that's behind your table of contents that's lime green in your 3-ring binder. Okay, here we go. Our first problem we're going to work on is 1/8 plus 2/7. I'm going to go with method 1. I'm going to take these two denominators and multiply them together. And 8 times 7 is equal to 56. Now, before I go ahead and do some math, I need to move my fraction over here a little bit because I need a little extra space. All right, now we're ready to go. Common denominator is 56. Okay, what did we multiply 8 by to make that 56? Well, we multiplied it by 7. Have I told you the story about fractions being brats? If I haven't, here's a quick story. I always think of fractions as brats. Some of you might have little brothers or sisters out there. I bet when you go out shopping with them, they're awfully bratty. And your parents are trying to buy you new shoes and they're too busy whining and complaining that they want new shoes also, well, so your parents probably cave in and they buy your sibling those shoes also. Think of fractions as brats. Whatever you give or take away, the numerator or denominator, you must do to the opposite. So for example, I just multiplied 8 times 7. If I multiply the denominator by 7, I have to multiply the numerator by 7. Now let's do the opposite side. 2/7. What did I multiply 7 by to make 56? Well, that was 8. So multiply the top. 2 times 8 is 16. Now we're ready to go ahead and add. 7 plus 16 is 23 over 56. Do you think that can be simplified to lowest terms? Nah, 23 is prime. The next number that 23 would divide evenly into would be 46, not 56. So we're done. There's our answer. Okay, so now we're going to subtract two mixed numbers. I have 1 1/6 minus 1 5/8. Now I'm going to use method 2. I'm going to find the least common denominator for 6 and 8. And the least common denominator for 6 and 8 is going to be 24. So notice the whole number 1. I want to go ahead and make sure I put that in front of my fractions. I don't want to forget about those. So what are we going to multiply 6 by to make 24? Well, 6 times 4 makes 24. So 1 times 4 is our new numerator of 4. Bring down my subtraction sign. And 8 times what number made 24? Well, that was 3. Notice, what is this fraction equal to that I am multiplying the numerator and the denominator by? For example, my 3 over 3, what is that equal to? That's equal to 1. So am I really changing the value of 1 5/8? Not at all. Oh, look here, 4 over 4, what's that value? That is equal to 1. I'm not changing the value of my mixed number I'm just making sure I have common denominators. So now I have 1 and 4/24 minus 1 and 15/24. And you're saying to yourself, Mrs. J, you can't subtract 4 minus 15. Yes, you can. You've learned this already. This is subtracting integers. It's a subtraction problem, so you could go ahead and copy, change, and do the opposite. What's the opposite of a positive 1 and 15/24? That's right, that's a negative 1 and 15/24. Are the signs the same or are they different? They are different. Do we add or subtract? We subtract, so I'm going to start with the numerator. 15 and 4, when I subtract those two numbers, we get 11. Denominators, now they stay the same. Now, trick question. Is the answer positive or is the answer negative? The answer is negative. Now, don't tell me it's because the signs are different. Answer is negative. That's your division and multiplication rule. The answer is negative because negative 1 and 15/24 is further from 0 on a number line. Got that? Good. Let's evaluate. I have t minus 4/5, and t is 5/6. So substitute. Whoops. Oh, I thought I had a mistake there. Nope, I'm good. Let's keep going. Common denominator for 6 and 5, 30. I multiply my first fraction by 5/5 and my second fraction by 6/6. 25 and 24. And that's a nice, neat problem. No regrouping, no negative numbers. A nice, neat subtraction problem. I can't say so much for our next problem with our problem solving. Let's go ahead and get into some really messy math. Two dancers are making necklaces from ribbon for their costumes. They need pieces measuring 13 3/4 inches and 12 7/8 inches. How much ribbon will be left over after the pieces are cut from a 36-inch length? There's two ways to tackle this problem. I'm going to take the approach of finding out how much ribbon do they need for their costume. So the first thing we're going to start with is adding 13 3/4 and 12 7/8. Common denominator for 4 and 8. Here's a trick. Always look at the smaller of the two denominators and see if it divides evenly into the larger of the two denominators. Does 4 divide into 8? It does. So let's use 8 as our common denominator. The 3 will now turn into a 6 because we're multiplying both 3 and 4 by 2/2. And now we can add. When we add 13 6/8 plus 12 7/8, I'm going to move this to give me a little bit of space. We end up with 28 13/8. Ugh, that's messy. I don't like the looks of that. I-O, it's off to math we go. Divide your numerator by your denominator. That 13/8 will equal 1 5/8. But don't forget, add the 28 whole number that's in front. So now we have 29 5/8. Woo! Are we done? No. We have 36 inches of ribbon. How much is going to be left over? So 36 inches of ribbon. Whoops, let me get rid of that. And my mistake over here. Thank you for being so patient. Minus 29 5/8. Now, I cannot subtract without a fraction. Let's borrow from the 36, make it a 35. I need a fraction next to this 35. I've just borrowed 1. Give me a fraction that's equal to 1. Here's a hint. We want it to have the same denominator as the fraction that's listed in the problem. That's right, that fraction's 8/8. Now we can subtract. 8 minus 5 is 3. And now 35 minus 29 is 6. And it's a story problem. What do we always put on a story problem? Who's going to tell me? Anissa, what's the answer? Right, we put inches on the end of our label, or on our problem. Here's a few for you to try. And tomorrow in class, we will do all practice of adding and subtracting fractions with unlike denominators. I hope you guys all have a great night, and I'll see you tomorrow. Bye.